In this lesson, we will continue our discussion on factoring by looking at some special factoring formulas. Now, what are these special factoring formulas? First of all, we will look at difference of two squares. Actually, you are familiar with it. You have seen earlier that multiplying the sum and the difference of two numbers gives you the difference of their squares. Do you remember that? Well, I'm sure you do. A plus b multiplied by a minus b. You remember that one? A plus b times a minus b is a squared minus b squared. In other words, you multiply the sum of two numbers by the difference of the same two numbers. It will be the same as the square of the first number minus the square of the second. A plus b times a minus b is a squared minus b squared. Well, this is multiplication. Factoring is opposite to multiplication. So, if you want to factor a squared minus b squared, can you write a squared minus b squared as the product of two factors? Yes. Read from right to left. A squared minus b squared equal to a plus b times a minus b. That means, how would you call a quantity like this? What is the specialty of this quantity? This is the difference of two squares. A squared minus b squared. And how do you factor that? That will be a plus b times a minus b. That's very simple. So, conversely, the difference of two squares can be factored as their sum multiplied by their difference. In other words, if I ask you to factor x squared minus y squared, can you factor that for me? This is a difference of two squares. Can you factor this for me? This can be factored as the sum of the two numbers, that is x plus y, multiplied by the difference of the two numbers, that is x minus y. So x squared minus y squared will be x plus y multiplied by x minus y. Okay, in the same way, or a squared minus b squared equal to a plus b times a minus b. Let's practice that with an example. Factor x squared minus 25. Alright, is this a difference of two squares? Yes, we can write this as the difference of two squares. How? 25 is the same as 5 squared. So x squared minus 25 is the same as x squared minus 5 squared. Alright, how do you factor this? X squared minus 5 squared, when you factor it, it becomes x plus 5 multiplied by x minus 5. So the sum of the two numbers is x plus 5. The difference of the two numbers is x minus 5. Therefore, the factors are x squared minus 5 squared is x plus 5 times x minus 5. So the moment you figure out to write this as the difference of two squares, the factors become very simple. Okay, let's try another one. Factor 1 minus 4x squared. Is this a difference of two squares? Or can you write it as the difference of two squares? Yes, 1 can be written as 1 squared. Is that right? 1 times 1 is 1. Now, what quantity squared will give you 4x squared? You see, 2 squared is 4, and therefore 2x all squared will be 4x squared. So, you can write 1 as 1 squared and 4x squared as 2x all squared. Did you understand that? This will be 2 squared times x squared, which is 4x squared. So 1 squared minus the quantity 2x all squared. So the first number is 1, the second is 2x. What are the factors? The sum of these two is 1 plus 2x, and the difference of these two is 1 minus 2x. And therefore, what are the factors? The factors are the sum multiplied by the difference, and therefore 1 squared minus the quantity 2x squared. Watch that parenthesis, very important. It is the quantity 2x that is squared there, and that will be 1 plus 2x times 1 minus 2x. Okay, another one. Factor x squared minus 81y squared. The task is to write it as the difference of two squares. Difference of one quantity minus difference of the square of one quantity minus the square of the other quantity. Well, the first quantity squared is easy. Tell me, what quantity raised to the power of 2 will give you 81y squared? 81y squared is the same as 9y, the quantity 9y raised to the power of 2. Is that right? Yes. Okay. Write this as the difference of two squares. X squared minus 81y squared is the same as the quantity x squared minus the quantity 9y raised to the power of 2. Now, the sum of the two numbers will be x plus 9y. Is that right? And the difference of the two numbers will be x minus 9y. So what are the two factors of this difference of two squares? The two factors are the sum multiplied by the difference, and that is x squared minus the quantity 9y squared. I want you to take special precaution here. 81y squared is the quantity 9y all to the power of 2. So the first factor is x plus 9y, and the second factor is x minus 9y. Okay. How about this one? Factor 1 over 49 minus z squared. Well, the second quantity is alright, it is a square of z. Can you write 1 over 49 as the square of a number or square of a quantity? Well, I'm sure you have enough background to do that. 1 over 49 can be written as 1 over 7 all to the power of 2. Is that right? Yes. Now look at this. 1 over 7 all to the power of 2. is 1 over 7 times 1 over 7. What is 1 over 7 times 1 over 7? 1 multiplied by 1 is 1. 7 times 7 is 49. And you can see 1 over 7 times 1 over 7 is 1 over 49. So 1 over 49 we can write as 1 over 7 all to the power of 2. Okay? So write this as the difference of two squares. 1 over 49 is 1 over 7 all to the power of 2 minus z squared. Alright, now you can factor it. The first factor is 1 over 7 plus z. That is the first factor. What is the second factor? 1 over 7 minus z. The sum multiplied by the difference. Therefore, the factors are the sum multiplied by the difference, and therefore 1 over 49 minus z squared is 1 over 7 plus z times 1 over 7 minus z. Okay, these are very simple, but you can make mistakes if you are not careful. Another one, factor 4a squared c squared minus 16x squared y squared. Can you write this as the difference of two squares? A quantity raised to the power of 2 minus another quantity raised to the power of 2. Can you write this 4a squared c squared as a quantity raised to the power of 2? Yes, you can. Now watch this. 4a squared c squared, I can write it as 2ac all to the power of 2. Did you get it? I'm sure you do. Minus 16x squared y squared can be written as 4xy all squared. Now, if you look at this, 2 squared is 4, a squared, c squared. So 4a squared, c squared is the quantity 2ac all raised to the power of 2 minus, if you look at this, 4 squared is 16, x squared, y squared. So 16x squared, y squared is the quantity 4xy raised to the power of 2. Now, once you write it like this, what are the factors? The factors are the sum of these two quantities, that is 2ac plus 4xy, that is one factor. The other factor is the difference, which is 2ac minus 4xy. Okay, let's write that now. Writing this as a difference of two squares. Well, one thing we overlooked. Now, what is the thing that we overlooked? Very important, I told you that you must remember, and it is very easy to forget. Just like I overlooked it now. Now, what is the thing that I overlooked? There is a common factor that you can actually factor out. What is that common factor? There is a number 4 in the first term, 16 in the second term. There is a 4 common. So factor out that 4. When 4 is factored out from 4a squared c squared, the remaining factor is a squared c squared. Minus, when 4 is factored out of 16, you've got a 4 left there. So the second term is minus 4x squared y squared. Well, now inside the parenthesis, we can write it as the difference of two squares. Alright, now you tell me, a squared c squared. What quantity raised to the power of 2 is a squared c squared? A squared c squared is the quantity ac raised to the power of 2 minus 4x squared y squared is the quantity 2xy raised to the power of 2. Okay, now you can factor this. The first factor is the sum of the two quantity, which is AC plus 2xy. The second factor is the difference of the two quantities, that is AC minus 2xy. And therefore, a squared c squared minus 4x squared y squared, that is just what is inside the parenthesis, is AC plus 2xy times AC minus 2xy. And therefore, what are the factors of this complete term? We have a 4 that is factored out. So the complete factors are 4 times AC plus 2xy times AC minus 2xy. Okay, so always remember the golden rule of factoring is look for common factors. Pull out the common factor first before we proceed with using any other factoring rules. Another one. 0.16p squared minus 0.81 q squared. Well, of course there are no common factors. Can you write this as the difference of two squares? Well, yes you can. You see, 0.16 is actually obtained by squaring 0.4. So, 0.16p squared is 0.4p raised to the power of 2. And 0.81 is actually the square of 0.9. You see? So, this is now 0.16 is the same as 0.4 squared. 0.4 times 0.4 is 0.16. So 0.4p raised to the power of 2 is the same as 0.16p squared. In the same way, 0.9q raised to the power of 2 is 0.81 q squared. So 0.16p squared minus 0.81 q squared can now be written as 0.4p all squared minus 0.9 q all squared. Now we have it written as the difference of two squares. We can now factor it. Alright. So that will be 0.4p all squared minus 0.9q all squared. And the first factor is 0.4p plus 0.9q. The sum of the two quantities is the first factor. The difference of the two quantities is 0.4p minus 0.9q, and that is the second factor. Therefore, we can say 0.16p squared minus 0.81 q squared is 0.4p all squared minus 0.9 q all squared. And what does that become when you factor it? It will be 0.4p plus 0.9 q multiplied by 0.4p minus 0.9 q. Okay, I hope you get the hang of factoring difference of two squares. Let's try this now. 144 minus the quantity a plus b all squared. Alright? First of all, write this as the difference of two squares. Tell me, what number squared is 144? You must know that. 12 squared is 144. Therefore, writing this as the difference of two squares, this become 144 become 12 squared minus the quantity a plus b all squared. This is now one quantity squared minus another quantity squared. And what are the factors? The first factor is the sum of the two. What is the sum? 12 plus a plus b. Now, what is the difference? You must be careful when you write the difference. What's the difference here? The difference is 12 minus, you must now use the quantity. The difference is 12 minus the quantity a plus b. You must use that parenthesis because you are subtracting a quantity. You see, there is no need for parenthesis when you add. But when you subtract, you have to have that parenthesis. And now distribute that -1. That will be 12 minus 1 times a is minus a, and minus 1 times b is minus b. So this is the difference. The sum of the two quantities is 12 plus a plus b, and the difference of the two numbers is 12 minus a minus b. And so the two factors are the sum multiplied by the difference, and so 144 minus the quantity a plus b all squared equal to 12 squared minus a plus b all squared, and that will be the sum of the two quantities will be 12 plus a plus b multiplied by the difference is 12 minus a minus b. That was a very good one. Okay, let's see if we got another one. Oh yes. Factor y to the power of 4 minus 16. Can you give it a try on your own? Y to the power of 4 minus 16. Write this as the difference of two squares. Now, you got to use the understanding of your exponents here. Y to the power of 4. Can you write this as the square of a quantity? Y to the power of 4. Yes, y to the power of 4 is the same as y squared raised to the power of 4. And 16 is 4 squared. Oh, I'm sorry. I got that wrong. Now, that will be y squared raised to the power of 2 minus 4 squared. So, y to the power of 4 is y squared all to the power of 2. You remember the power rule? Y to the power of 2 all raised to the power of 2 is y to the power of 2 times 2, y to the power of 4. So, write y to the power of 4 as y squared raised to the power of 2 minus 16 is 4 squared. We have now written this as the difference of two squares. Okay. Let's continue factoring it. So writing this as the difference of two squares, you have y squared all to the power of 2 is your y to the power of 4 minus 16 is 4 to the power of 2. Well, we can now factor this. What is the sum of these two? The sum of these two will be y squared plus 4. And the difference of these two is y squared minus 4. Alright, so what are the factors? Y to the power of 4 minus 16 therefore can be written as y squared plus 4 times y squared minus 4. Now, is it over? Have we finished factoring it? Well, apparently not. Why not? Because y squared minus 4 can still be factored. You see, you must understand y squared plus 4 cannot be factored. The sum of two squares cannot be factored. But the difference of two squares, y squared minus 4, can be factored. This is the difference of two squares. 4 is 2 squared. So we can factor this further. Don't confuse again. Y squared plus 4 is the sum of two squares. You cannot factor it. But y squared minus 4 is the difference of two squares. We can factor it further. Y squared minus 4 is a difference of two squares. And we can write it as y squared minus 2 squared. What are the factors of y squared minus 2 squared? That will be y plus 2 times y minus 2. So, we are factoring this quantity, y to the power of 4 minus 16. We obtained this result, y squared plus 4 times y squared minus 4. And now you know y squared minus 4 is factored as y plus 2 times y minus 2. Therefore, what is the complete factorization of y to the power of 4 minus 16? It will be y squared plus 4 times, in place of y squared minus 4, I have y plus 2 times y minus 2. Okay, I hope you understood it. It's a very important type of problem. Okay, so far we were looking at one type of special factoring formulae, and that is the difference of two squares. The second type of special factoring formulae is the perfect square factoring. We actually did one of that in the last class. When you factor a given trinomial, the factors are both the same. Have you seen that before? And that can be therefore written as that factor raised to the power of 2. That is a perfect square factoring. What is a perfect square, by the way? A perfect square. Well, there are many numbers that are perfect squares. Is that right? Well, 4 is a perfect square. Why? Because 4 is 2 squared. 9 is a perfect square because it is 3 squared. 16 is a perfect square. Why? Because it is 4 squared. Well, algebraic expression a plus b all squared is a perfect square. So this is a perfect square. And factoring that involves a perfect square, we will be looking at the perfect square factoring. Alright, let's do this. Factor 36p squared q squared plus 12pq plus 1. Well, this is a trinomial, the method we already developed. The first term is 36p squared q squared. The last term is plus 1. The middle term is 12pq. Alright, do you get a clue by looking at it? If you look at this, the last term is 1. The first term has a coefficient 36. 36 can be written as 6 times 6. And 6 plus 6 is 12. Well, that's the clue. I don't think many of you even got what I said, what I said now. Alright, what's the first method? Take the first term, 36p squared q squared, and factor it. 36p squared q squared can be factored as 6pq times 6pq. Is that right? Yes. So let's write it like side by side. 6pq and 6pq. And 1, there is only one way to factor it. Because all these signs are positive, plus 1 can be factored only as plus 1 times plus 1. Write it the normal way. Now multiply diagonally. 6pq times 1 plus 6pq times 1 is 12pq. And therefore the first factor is 6pq plus 1. And the second factor is also 6pq plus 1. You see, both factors are the same. Therefore, we say 36p squared q squared plus 12pq plus 1 is 6pq plus 1 times 6pq plus 1. And how do you write it as a perfect square? Is 6pq plus 1 the quantity 6pq plus 1 raised to the power of 2. That's a perfect square. So this trinomial is a perfect square. Try another one. Factor a to the power of 4 minus 2a squared b squared plus b to the power of 4. Are there any common factors you can pull out? I don't see any. Okay, that means we do it using the method for the trinomials. Now, this is the first term, a to the 4. The last term is b to the 4. And the middle term, what's negative 2a squared b squared. Okay, let's begin by factoring a to the 4. A to the 4 can be factored as a squared times a squared. Similarly, b to the power of 4. Can you tell me how you will factor b to the power of 4? I want you to tell me. What is the important thing you need to consider here? The last term is positive and the middle term is negative. Therefore, both factors of the last term must be negative. Therefore, how do you factor b to the power of 4? B to the power of 4 needs to be factored as negative b squared minus times negative b squared. Negative b squared times negative b squared is positive b to the power of 4. Now, why have we used the negative factors? Because the middle term is negative. So we write b negative b squared and negative b squared below the respective a squared. And now multiply diagonally. Negative b squared times a squared is negative a squared b squared. And the next negative b squared times a squared, adding them together, look at this, negative a squared b squared added to negative a squared b squared is negative 2a squared b squared. Therefore, what are the factors? The first factor is a squared minus b squared. The second factor, well, you notice here, a squared minus b squared is a difference of two quantities. That can still be factored. So, the first factor is here, a squared minus b squared, and a squared minus b squared can be further factored, which is a plus b times a minus b. That is our first factor. Similarly, what is our second factor? Our second factor also is a squared minus b squared. That means this can also be further factored, a difference of two quantities. That will also be a plus b times a minus b. That means this trinomial can now be factored as how? A plus b times a minus b times a plus b times a minus b. There you are. You see, this is your first factor. A squared minus b squared is a plus b times a minus b. And the second factor also is a plus b times a minus b. And now, a plus b times a plus b is the quantity a plus b to the power of 2. And a minus b times a minus b is the quantity a minus b to the power of 2. Alright, so that will be a plus b times a plus b times a minus b times a minus b, which is written as a plus b all squared times a minus b all squared. Isn't that a beautiful method of factoring? Yes. So please go through this one more time and learn it. Okay, let's do another one. Factor 36y squared minus 60y plus 25. Are there any common factors you can pull out? 36, 60, 25, no common factors. Alright. Can you look at this and form some opinion about how to do it? Well, I would go like this. 36y squared is 6y times 6y. And 25 is 5 times 5. And then I would say 6 times 5 is 30. And 30 added to 30 is 60. You see, I have formed a mental picture of this already. Okay, let's start with the first term. This is a trinomial. The first term is 36y squared, and that is factored as 6y multiplied by 6y. You agree with me? I hope so. 36y squared is 6y multiplied by 6y. Alright, I want you to now tell me. The last term is positive 25. The middle term is negative 6y. Tell me, how are you going to factor the last term? You need to factor positive 25, knowing that the middle term is negative. You remember how to do that? When the last term is positive and the middle term is negative, both the factors of the last term must be negative. So 25 will be factored as negative 5 times negative 5. But first let's write this 6y and 6y side by side. 25 is factored as negative 5 times negative 5. I hope you understand why. And write that negative 5 and negative 5. It doesn't matter, they are all the same. Alright, let's multiply diagonally. Alright, negative 5 times 6y is negative 30y, and this negative 5 times 6y is also negative 30y, and add them together, negative 30y added to negative 30y gives you negative 60y. And therefore, what are the factors? The factors are, the first factor is 6y minus 5. The second factor also is 6y minus 5. So both factors are 6y minus 5. Therefore, this trinomial 36y squared minus 60y plus 25 is the quantity 6y minus 5 all squared. Perfect square factors. Okay, look at another one. Factor 9t squared plus 24tr plus 16r squared. This is again a trinomial. Are there any common factors you can pull out? No. 9, 24, 16, no common factor. T squared, t, and there is no t. There is no r in the first term. There are no common factors. So we proceed by following the trinomial method. What is that? Factor the first term. Can you factor 9t squared for me? What is the obvious way to factor 9t squared? I'm sure you know it. 9t squared is 3t multiplied by 3t. Isn't that simple? Yes. Similarly, now, there is no difficulty at all here because all the terms are positive. Alright, how do you factor 16r squared? First of all, write 3t and 3t side by side. 16r squared is 4r times 4r. Write them below each of these. What do you get if you multiply diagonally? 4r times 3t, 4r multiplied by 3t is 12rt. And this 4r multiplied by 3t also is 12rt. And 12rt added to 12rt is 24rt. tr and rt are the same thing, which is the middle term. And so, what are the two factors of this trinomial? The first factor is 3t plus 4r. The second factor is also 3t plus 4r. Therefore, we say both factors are 3t plus 4r. And we will write 9t squared plus 24tr plus 16r squared equal to the quantity 3t plus 4r all to the power of 2. Another example of a perfect square factoring. I think we did a number of these. I'm sure you feel pretty comfortable with it. Now do some more from the homework. And now, we have done two types of special factoring formulas so far in this lesson. Difference of two squares and the perfect square factoring. Well, perfect square factoring is not really a particular method. It's a trinomial. So whatever method we developed as a trinomial can be used there. Now, the third special type of factoring is called the sum and difference of two cubes. Now, I don't want you to pay a lot of attention to it, but it'll be nice to know this. What I'm going to do is I'm going to give you the two formulae and ask you to use that in factoring the sum and difference of two cubes. For example, you need to learn this formula. Keep that with you. A cube plus b cube is a plus b times a squared minus ab plus b squared. Alright? And a cube minus b cube is a minus b times a squared plus ab plus b squared. This is called the sum of two cubes. The sum of a cube and b cube. And this is called the difference of two cubes. That means if you know these two formulae, you can factor any sum of two cubes or difference of two cubes. And so we will use these two formulas to factor the sum and difference of two cubes. What you need to do is identify A. A is the first quantity. And then identify the second quantity as your B. And just plug in to their relative respective positions. And that will be enough. Okay, let's do this. Factor a cube plus 125. A cube plus 125. Now, can you write this as the cube of, the first quantity is the cube of A. Can you write 125 as the third power of a number? What number raised to the power of 3 is 125? Well, I have actually given that to you early. We have talked about it. Look at this. 5 times 5 is 25. 25 times 5 is 125. So 125 is 5 raised to the power of 3. So this can be written as a cube plus 5 cube. Now, you have the formula. Look at the formula here. A cube plus b cube is a plus b times a squared minus ab plus b squared. Now, in this case, a is the same as a. We don't need to do any change there. But in place of b, we will use 5. So what all we need to do is bring down this formula and keep a as a itself, and in place of b, use the 5. That's all what you need to do. So replace your a by a. Of course, a is the same as a. And replace your b in this as your 5. So what does that now become? A cube plus 5 cube is a plus, look at this, a plus b. In place of b you have 5 times a squared minus ab, a times 5 plus b squared is 5 squared. I have used colors to identify that. What all we did here is in the formula b is replaced by 5. Wherever you had a b, it has been replaced by 5. And now simplify this. This will be a plus 5, and this when simplified gives you a squared minus a times 5 is 5a plus 5 squared is 25. And that is the result. Okay. Let's do one more. And that is the difference of two squares. Factor w cube minus 216. Obviously, The formula we want to use here is the difference of 2 cube, a cube minus b cube. What is the formula for that? A cube minus b cube is a minus b times a squared plus ab plus b squared. Okay, first of all we need to write 216 as the third power of a number. Can you tell me what number raised to the power of 3 will give you 216? Well, the obvious candidate is 6. 6 times 6 is 36. 36 times 6. Can you do that in your mind? 36 times 6 is 216. So 216 is 6 raised to the power of 3. So we will write this as w cube minus 6 cube, which means in place of your a you have w. So this a can be replaced by this w, and the b can be replaced by 6. That's all you need to do. So in this formula, a minus b will become w minus 6 times a squared becomes w squared plus ab become plus w times 6. That will be 6w plus b squared become plus 6 squared. There you are. So a equal to w and b equal to 6. Therefore, w cube minus 6 cube is w minus 6 a minus b times a squared is w squared plus ab is w times 6 plus b squared is 6 squared. And simplify, that will be w minus 6 times w squared plus 6w plus 36. And that's all to it. I want you to practice with some more examples from the homework. Alright? After watching every lesson, you've got to complete the homework. And when you don't understand anything in that homework, I have worked out all the homework problems for you. Refer to that. And if you need further help, let me know. Okay, I think I'm going to close this lesson here. We have now done many methods of factoring. Can you quickly recall some of the methods that we've done so far in factoring? The first method is factoring the common factors from all the terms. The second method we discussed was factoring by grouping. Then we started factoring trinomials. We spent 2 lessons on factoring trinomials. So you know that it's a very important factoring process. You must be familiar with it. Then we looked at some special factoring formulae in this lesson. The difference of 2 squares. A squared minus b squared can be factored as a plus b times a minus b. Then we looked at perfect square factoring. Then we looked at the sum and difference of cubes. That is these formulae. Well, all these factoring methods are important and you must be familiar with them. And in the next lesson, we are going to use factoring to solve equations. Alright? That will be very interesting. And I will see you for that lesson a little later.